Right now, 15 billion miles from Earth, something is dying. It weighs 1,800 pounds. It moves at 38,000 miles per hour. It carries a message from humanity to the cosmos. And it's running out of time. Voyager 1 launched in 1977. For 47 years, it has traveled farther than any human-made object in history. It left our solar system. It entered the void between stars. It became the first ambassador of Earth to the galaxy. But the power is fading. The instruments are shutting down one by one. And soon, very soon, Voyager will go silent forever. This is not just the end of a mission. This is the beginning of an eternal journey that will outlast our civilization, our planet, and possibly our sun. September 5th, 1977. NASA launched Voyager 1 from Cape Canaveral. The mission objective was simple: explore Jupiter and Saturn, then keep going. Engineers gave it a lifespan of 5 years. They built it with 1970s technology. The computer aboard Voyager has 240,000 times less memory than your smartphone. The entire data storage capacity is 67 kilobytes. But NASA scientists did something extraordinary. They designed Voyager to survive the harshest environment imaginable: extreme radiation, temperatures near absolute zero, complete isolation, no maintenance, no updates, no second chances. The spacecraft carries 3 radioisotope thermoelectric generators. These devices convert heat from decaying plutonium, 238, into electricity. In 1977, they produced 470 watts of power. Today, they produce 249 watts, and dropping by about 4 watts every year. Every instrument aboard Voyager requires power. The cameras, the magnetometer, the plasma detector, the cosmic ray sensor, and most critically, the transmitter that sends data back to Earth. As power decreases, NASA faces impossible choices. Which instruments do we shut down? What data do we sacrifice? When do we accept that the mission is over? Voyager 1 reached Jupiter in March 1979. It discovered active volcanoes on the moon Io. It captured images of Jupiter's Great Red Spot in unprecedented detail. It revealed complex ring systems and violent atmospheric storms. The spacecraft used Jupiter's gravity to accelerate towards Saturn. This gravitational assist increased Voyager's velocity by 35,000 miles per hour. Without this boost, a mission would have been impossible. November 20th, 1980. Voyager arrived at Saturn. It flew within 77,000 miles of the cloud tops. It studied the rings, discovering structures scientists called spokes. It passed close to Titan, Saturn's largest moon, measuring its atmosphere. Then came the critical decision. Voyager could continue to Uranus and Neptune, or it could fly close to Titan for better data. NASA chose Titan. This trajectory sent Voyager 1 upward, out of the plane of the solar system, into the void. For 35 years, Voyager traveled through the heliosphere. This is the bubble of charged particles blown outward by our sun. It extends billions of miles in every direction. It protects the solar system from interstellar radiation. But the heliosphere has an edge, a boundary, where solar wind weakens and interstellar space begins. Scientists called it the heliopause. August 25th, 2012. Voyager 1 crossed the heliopause. At that moment, it entered interstellar space. It became the first human object to leave the solar system's protective bubble. The instruments detected the change immediately. Cosmic ray levels increased by 9%. Solar particles disappeared almost entirely. The density of plasma changed. Voyager was now swimming in the ocean between stars. The distance from Earth, 11.7 billion miles. The travel time for radio signals, 17 hours one way. The speed, 38,000 miles per hour relative to the Sun. NASA engineers monitor Voyager through the Deep Space Network. 3 facilities around the world: California, Spain, Australia. These massive radio antennas listen for Voyager's faint whisper across the cosmos. The signal strength, 20 watts. By the time it reaches Earth, the power is 1 billion times weaker. It's like detecting a single snowflake in a blizzard from across the continent. Since 2019, NASA has been shutting down instruments. The plasma spectrometer, the ultraviolet spectrometer, the infrared radiometer. Each shutdown buys a few more years of operation for the remaining systems. In 2024, engineers shut down one of the heaters, protecting the cosmic ray instrument. The temperature dropped to minus 74 degrees Fahrenheit. The instrument continued working. It exceeded all design specifications. But the math is unforgiving. By 2025, Voyager will have 220 watts of power. By 2030, less than 180 watts. By 2036, the power may drop below the threshold needed to operate any instruments at all. The final shutdown will happen gradually. One day, Voyager will transmit its last reading. The signal will travel for 22 hours across space. NASA engineers will receive it. They will log it. And then, silence. After the power dies, Voyager continues. It will drift through the galaxy for billions of years. It will never stop. It will never land. It will never decay. In 40,000 years, Voyager 1 will pass within 1.6 light-years of the star Gliese 445. It will be a dead relic by then, frozen solid, covered in cosmic dust. But it will still be moving. In 300,000 years, it may enter the Oort cloud surrounding another star system. The gravitational interactions could alter its trajectory slightly, but it will continue. In 1 billion years, the sun will have expanded into a red giant. Earth will be uninhabitable or destroyed. Human civilization will either have spread across the galaxy or gone extinct. But Voyager will still be out there, carrying its golden record. Here is where the story becomes strange. Voyager carries a time capsule. A golden phonograph record, 12 inches in diameter, coated in gold. It contains 116 images, greetings in 55 languages, sounds of Earth, and 90 minutes of music from cultures across the planet. The record includes instructions for playback, a diagram showing Earth's location using pulsars as reference points, a representation of hydrogen, the most common element in the universe. But here is the question. What are the odds that any intelligence will ever find it? The galaxy is 100,000 light-years across. It contains 200 billion stars. Voyager is one object, 12 feet long, moving at 0.006% the speed of light. The chances of encounter are mathematically zero. Even if an alien civilization detected Voyager, they would need to intercept an object moving at 38,000 miles per hour. They would need technology far beyond our current understanding. They would need to care about a random piece of metal drifting through their space. And yet, NASA built the record anyway. Scientists like Carl Sagan insisted on it. They knew the odds, they understood the futility, but they did it because it mattered to us. The golden record is not for aliens, it is for us. It is a message we sent to ourselves, acknowledging that we exist, that we create, that we hope. It is a bottle thrown into an ocean so vast that it makes our cosmic ocean look like a drop of water. There is something deeply unsettling about this. Voyager will outlive everything we know. It will exist long after the last human takes their last breath. It will drift through a galaxy that has forgotten Earth ever existed. And it will carry evidence that we were here. This is not a mission. This is a monument. An accidental gravestone for humanity, launched before we even knew we needed one. Voyager 1 will go silent soon. The exact year is uncertain. Maybe 2030, maybe 2036, but the silence is coming. When it happens, the spacecraft will continue its journey. It will pass through regions of space we can barely imagine. It will witness cosmic events we will never detect. It will drift past stars that do not yet have names. This is the final countdown, not for the probe, but for our connection to it. Voyager is not ending. We are ending. Our ability to hear it, to track it, to know where it is. That is what dies. Somewhere out there, billions of miles away, a machine built by humans continues to function. It measures cosmic rays, it records magnetic fields, it stores data nobody will ever read. And eventually, it will freeze solid and drift forever. This is what immortality looks like. Not consciousness, not memory, just motion. Eternal, meaningless motion through a universe that does not care. Subscribe to Vault Insights, because some stories do not have endings. They just continue, forever, into the dark.